Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. Hope the same thing for you guys. So if you guys have any doubts till this point, please make sure that you guys ask in the comment section. We'll take up and we'll solve your doubts. Okay. So today is gonna be a continuation of previous session where we have introduced you what is what is hyperparameter tuning, how it works, and different techniques. Okay. Today is a continuation. Okay. So if you guys are till this point, please make sure that you guys watch all the previous session videos so that you guys can have a better understanding of what we are talking. Okay. So in the previous session, we have introduced you two different techniques. One is grid search CV and then random search CV for handling the hyperparameter tuning. Let us continue that in this session. Okay. Today we're gonna see one more technique. So I think 2 to 3 more techniques. One is Bayes optimization. Okay, Bayesian optimization. Bayesian optimization uses a probabilistic model to guide the search for optimal hyperparameter combination, leveraging information from the previous evaluation. So what is an advantage of this method? Effective and efficient, particularly for a complex and expensive models. Okay, what is a con? Can be computationally expensive to set up and train the optimal probabilistic model. Okay, so this Bayesian optimization, it's based on Bayes rule. Okay, so it is a kind of mathematical equation. Okay, don't worry about this guys, because like we are having a package in SQL for this also. You just import and apply your data set and you can have it. Okay, so what is the major advantage of this? It is very effective and it is very good model for hyperparameter tuning whenever you're going for a complex data set. Okay, but what is the disadvantage? Since we need to have this model as a separate training, the probabilistic model, for this Bayesian optimization, it leads to more computationally cost, as well as it requires more resource. Okay, and also inference is somewhat different. Okay, when compared to the grid search and random search. So this is what all about this Bayesian optimization. Hope you guys are able to understand. Okay, if you guys have any doubt, just ping in the comment section. Okay, Bayesian optimization means only one thing comes to your mind. What is Bayesian optimization? This kind of optimization works on a probabilistic kind of model, that is Bayes rule. Okay, it works based on Bayes rule, and that the major advantage of this, it gonna be work for very complex data, but it gonna take, what is the disadvantage? It gonna take more computation in order to do the optimization. Okay, so let's move on to the next slide. Okay, yeah guys, next thing, I love this method. Okay, actually I really love this method. This is one of the way of doing hyperparameter tuning, that is cross validation strategy. Okay, cross validation technique ensures that your models performs in a robust and generalist well to unseen data by partitioning the data into multiple folds for training and evaluation. So I will say in a simple manner, we are having 10 data points. First 8 for training, another 2 for testing for the first iteration. Second iteration, first 8 data points for training and last 2 for testing, right? Next time what I will do, first 2 for testing, last 8 for training. Next what I'll do, middle 2 for testing, other things for training. So like that, I will try to make all the data for training as well as for testing. What happens means now the model get to know about all the data and it becomes generalized. So this is a way of doing the cross validation. Okay, hope you guys have understand, because like I enjoy this technique guys. Okay, you need to simply fold your hands. You just need to do from SQL and just import this cross validation, and you apply your model together with your dataset, and it will do everything for you. Just you need to mention how many folds you need. That's it. Okay, yeah, what are the technique we are having? First is k-fold cross validation. The data is divided into k-fold. For example, 2 means 2 folds with k minus 1 folds used for training. For example, if it is 2 fold, 1 fold is used for training and 1 fold for testing, and the remaining fold for validation repeat for k times. That's it. Okay, so this is what's the k-fold. Next, stratified k-fold cross validation, similar to k-fold, but ensures that each fold maintains the same class proportion as of original dataset, crucial for imbalanced dataset. Consider you are having a heart disease prediction where the person has a heart disease or not. For a heart disease, the patient has a heart disease, you are having 50 records, and for a patient don't have a heart disease, we are having 50 records. When you split this dataset, you should have a similar range of ratio of person have a heart disease and person doesn't have a heart disease in the same ratio whenever you split for this hyperparameter, that is for k-fold cross validation. Then only you are able to get the proper accuracy, improve the accuracy. Okay, leave one out cross validation. Every single data point is used as a validation set, with the remaining data used for training, providing a high variance but low bias. Okay, The thing is here, leave one out cross validation. I don't know like how much effectively it works, but I will not suggest, but it is also one of the method you guys need to understand. Leave one out for cross validation. Leave one out cross validation. What means, if you are having 10 data points, first iteration, first data point for validation, second all other for training, second data iteration, second data point for validation, all other for training, third iteration, third data point for validation, all other for training, fourth iteration, fourth data point for validation, all other for training. Similarly for a 10th iteration, 10th data point is for validation, all other for training. Like that you do. So it is like more like a simple and start way of doing this hyperparameter tuning by using cross validation. So I will not suggest leave and word cross validation, because like it leads to overfitting, but like this is one of the way that is available for doing the hyperparameter tuning. Okay, you can also use this method. Okay, so yeah, these are the ways that cross validation strategy which helps for hyperparameter tuning. Okay, hope you guys can able to understand. Right now you guys can able to have an idea of what kind of algorithm we need to use, what kind of strategy we need to use to optimize our results. Okay, that's right. So when you need to use k-fold, when you need to use stratified k-fold, and when you need to use leave or no cross validation. Okay, now let us move on to the next thing. Yeah, hyperparameter tuning best practice. Okay, let's see what are the best practices that we are having for hyperparameter tuning. To optimize your hyperparameter tuning process, follow best practice for better result and effective exploration of the hyperparameter spaces. First, define a clear objective. Clearly define your goal for tuning, whether it's maximizing accuracy, minimizing error, or balancing both. Okay. For example, guys, what is this first point says? Let us understand. Define a clear objective. Okay. You are building a model where whether you need to improve the accuracy, or you need to reduce the loss, or you need to maintain the both. For example, you are building something like a linear regression model, whether you need to improve the accuracy, that is R2 score, whereas for regression, or you need to reduce the error, that is loss, that is mean square error, or you need to maintain both of this, that is accuracy, R2 score, as well as mean error. So that's what a clear objective that you guys need to mention. That is called defining a clear objective. Okay, let us see what is next. Choose the right search strategy. Select the appropriate search strategy based on the complexity of your model and the size of hyperparameter space. Okay, what kind of search strategy is gonna use? Whether you're gonna use the random search or grid search. Okay, grid search, each and everything that you're gonna go it out. Whereas random search, randomly pick the things. Okay, if your data set is very large, go for a random search, and then you go for a grid search. Whatever gives the accuracy, you could go. If it is very small, go for a grid search and then random search. Whichever the high accuracy, you just choose it. Okay, then let's move on to the next thing. Use cross validation. Employ cross validation technique to ensure the robustness and generalizability of your model performance. Okay, cross validation, where you will be splitting your model to k-fold and then using some fold for training and some fold for validation, such that you will make your model to avoid overfitting and also generalize. Okay, then finally you are having monitor the performance metrics. Track relevant performance metrics throughout the tuning process to guide your decision and access progress. Okay, guys, we can say anything, right? When you are training your model, when you are applying your fine-tuning process, while you are monitoring only, you can able to understand, okay, this kind of changes to hyperparameters works well, these kind of changes to hyperparameters doesn't work well. Okay, these are the things that you can able to understand once you apply the hyperparameter. That is what we are saying. Data science is purely trial and error method, guys. It is completely black box, but like we are trying to open the black box for you. Okay, but end of the day, it's going to be trial and error method. Whenever it gives you guys the more result, choose those parameters and just go for model training and testing and prediction, and you get the better results. Okay, so yeah, guys, this is all about best practices of hyperparameter tuning. Hope you guys can able to understand. If you guys have any doubt, just ping in the comment section. We will take up and we will solve your doubts. Okay, let's move on to the next thing. Okay, guys, final thing, we're going to conclude this. Okay, so conclusion, hyperparameter tuning is crucial aspect of building high performing machine learning models. That's true, right? So without hyperparameter tuning, what happens means there is a point where we gonna be differ from others, right? Now you guys know, the person who doesn't know the data science, they can also apply any kind of model. The difference between them and us, We know the black box behind it, how the model works. Also, hyperparameter tuning such that we're gonna improve the model performance. The person who doesn't know data science, they can able to get the accuracy whichever the model they can load and apply. That's it. They are not able to fine tune the model because they doesn't know how the fine tuning works. What are the parameters that the model has? How to tune it? Those things the person who doesn't learn the data science, right? They don't have. Okay, that's a one thing. Then, by understanding the different techniques, best practice, and the importance of cross validation, you can significantly enhance your model's performance and achieve optimal results in your data science. So field, any kind of field. Okay. So yeah, guys. So this is what the thing. Whenever you are applying, whenever you are just creating a model, right? One thing from my side. Whenever you just create the model, just create the model. First of all, load the data set, go for any model that is applicable for the data set. That is a classification, regression, clustering, dimensionalization. There are many models available. For our data set, what is the model you need? You just apply it, then you get the result. And once you get the request result and accuracy, try to fine tune it by using hyperparameter result out of it. That's it, guys. That's all about what is hyperparameter tuning. I hope we have given a gist of what is hyperparameter tuning before moving for the next big topic that is called as a big and interesting topic called as association tools. Hope you guys have enjoyed the session. So we have enjoyed a lot. If you guys have any doubt, just ping in the comment section, guys. We will take up and we will solve your doubt because like we are here to mentor you, guide you, and make you to go for a top 1% who are like well versed in the data science field. Okay, so yeah, guys, that's from my side. So and one more thing, guys, we are every day we are just uploading a new video. So please subscribe to our channel and then press the bell icon so that you will get the notification whenever we are just uploading a new video. So yeah, guys, thank you. See you all in the next session. Bye, guys. Until next session. Bye, guys. Take care. Bye.